Good morning, everyone. This is Miles tuning in from a recording. I unfortunately couldn't make it for a live session, so we're doing it in two parts. I'll be sharing this recording, and then Robert will be continuing the session on Saturday. So, for our second session, we're going to do a few things. We are going to talk about the life of an auditor and some of the skills that auditors are typically bringing to the table. We're going to review a little bit on audit reports, take a look at an example report, and kind of just show how an auditor reads these and how you should be reading them. We're also going to touch on a few popular attack vectors. These are going to be some really great intros to finding your first vulnerabilities. And then lastly, Robert is going to continue with the CTF activity. So, in the life of an auditor, you have to really focus on continuous learning. If you see that how most auditors engage in the community, they're always talking about studying new topics and learning about new attack vectors. These are great ways to stay in the know so that you can serve, your clients the best way possible. Next is CTFs. This is also a part of your continuous learning journey, right? When you're doing CTFs, you're actively exploiting local contracts. You are building that muscle of how an attacker commits that attack or commits that crime, if you will. And so you're learning how to actually do that versus just the theory of understanding an attack vector. Next, it's great to make sure you're focusing on building, right? As developers, they are building every single day. They're coding, they're building these skills, and then they're creating something. And as an auditor, if you have that perspective, if you go through the process of developing an application or an app, if you go through that process and also build that muscle, you begin to think like a developer, which helps you even better think like an attacker, right? Because you are now operating from the standpoint of, okay, I've been a developer, I've built this app before. What are some of the issues or things I may have ran into that could cause some vulnerabilities? Next is participating in bounty contests. This is a great way to showcase your skills, but at the same time, learn new things. These are literally protocols that post their code publicly and allow you to go and audit it. And at the same time, you can get paid. Next is networking with other auditors and protocols. I should have said developers, but really what this is for is in this community, it's all about helping each other and growing together. And so it's really crucial that you network with other auditors. You get to learn from them, you get to be mentored by them or mentor someone else, and you just contribute and help the space get better. Next is networking with developers and different protocols. Not only is this a great way to have potential clients or find potential job opportunities, but you will learn so much if you're able to work with a protocol or maybe even, be a partner with them or an advisor to them from a security standpoint. You can learn so much from just engaging with those new and interesting startups out there that may not have a lot of money, but they may have a lot of experience to share and to teach. So next is learning in public. So a big part of the Web3 community is sharing your process, your journey um, throughout, basically sharing your knowledge throughout your journey. Excuse me. And the reason why this is important is because it showcases your skills. It allows other people to learn from you, and it holds you to a standard of working. If you know that project you're going to that if you know that project is going to be evaluated by someone, or if your audit is going to be seen by someone, you're going to take a certain level of care to what you're doing. So the Web3 community has really embraced learning in public. I think this also just goes along with the culture of Web3 decentralization. It's all about making sure it's open and accessible to everyone. And so a part of this is your GitHub. Make sure If you're doing CTFs, you're building small projects, whatever it is, push it up to GitHub and make it public so that someone could see this in the future. Also, with public contests, this is a great way to learn in public. We talked about the learning piece of it, but it's also a great way for just someone to go and look. Okay, let's go look at Miles's previous audits and public contest. What was how were his write-ups? What was the quality of that? So that's a great way to just show you're being engaged, you're engaging in the community. It helps with building your brand. Next is tweeting. The crypto community really really loves Twitter, and so this is a place where you can connect with folks at the same time. It's also a great way to learn and to teach others. And this basically, a lot of this summarizes what I was getting at here in the last bullet point. But it really is beneficial to share what you're learning to everyone else. Um, this is very crucial into building up the ecosystem and making sure we're all working together to protect Web3. Next is audit reports. So a lot of what we do as auditors results in generating an audit report. So not only do we find bugs and try to write proof of concepts and try to exploit them, but at the end of the day, after we're done with what we're doing, I don't know why this showed up. At the end of the day, after we're done with what we're doing, we need to draft an audit report. And so essentially what this is, it's a collection of findings from the protocol that you are currently auditing. Um, Not only is this something we have, you create, but this is a great pathway into becoming an auditor, is by learning from previous reports. It's a great way to study and to also understand, how our vulnerability is structured. So we're going to take a look at a sample audit report and take a look and just review some of the things that we can start looking at as I guess entry level auditors into this space. I'm going to go ahead and say that it's really best to start with the NCs, which are non-criticals, and the low vulnerabilities. These are the findings that are a little bit easier to understand and maybe easier to spot in the code base. So we're going to take a look at these. And then I would say to work your way up to mediums and highs throughout your progression in your audit journey. But today we're just going to take a look at a few lows. So this is this is code for Arena. This is a bounty contest, and this is the audit report that is generated. A little bit about how audit report is structured is you have an overview section, which essentially tells you a little bit about the code, about who participated in this audit. Next, you have a summary section, so it talks about so not only does it talk about the code, but it may talk a little bit about the findings that were included. You have the scope, so this is really important. Your scope is basically what was the thing that the auditors were reviewing. You have to cap the code that the auditors are going to be reviewing. It can't be an unlimited scope. It can't be, a changing scope. The scope is locked at a specific commit hash, and the auditors review that commit hash only. Next is your findings. So it's broken out into highs, mediums, lows. This is the NCs I was talking about. It's non-critical issues. And there's also gas optimizations. These are really good for new auditors to dive into as well. And so just a little bit about the high, mediums, and lows. There's not necessarily a set standard for these, but there is an agreed upon standard upon the Web3 security community that highs are typically those things that are very likely to happen and maybe a little bit easier to exploit, as well as it results in some denial of service, or a large or significant amount of funds being lost. And if we kind of go to mediums, this is more so those findings that are probably harder to perform, or those attacks that are harder to perform, and they may have just a little less significance in terms of high vulnerabilities, because you may not be able to essentially like break the protocol completely, but it may lead to breaking some other things, or just some functionality that's unwanted. Um, and then you have your lows. These are typically things that are in the range of, not very likely to happen, or it may cause, a lower impact. There's not really a loss of funds. It could just be those things where um, it's functionality that may lead to other bugs, which can kind of build on top of each other to create some more vulnerabilities. So um, this is typically what those are. And then non-criticals and gas are those things that really aren't necessarily issues, but they may be able to lead to some type of issue, or just some small bug. But these are things that are not, I don't want to say not important, because they can lead to things. But for the time being, non-criticals are things that really don't impact the protocol much. Another way this could be a non-critical, or another reason that a finding could be non-critical, is if maybe the attacker knows there's a potential issue, but they don't really know how to attack it. So that might go in the non-criticals. In other reports, you may see this as informationals. It's just things that auditors typically do to add to the audit report. And then a little bit on gas optimizations. This is really unique to Ethereum. Um, as we all know, gas is essentially the payment that we spend to make transactions. And so if there's better ways to make these payments cheaper, this is also just a great value add to the audit report. So not necessarily going to dive too deep into reading these findings, but as you are stepping into the space, these lows and non-criticals in gas are very great to do. So let's, for example, I'm trying to think. Excuse me. I'm trying to think of some ones that everyone would understand. So, okay. So this is a non-critical issue. So NatSpec is missing for the following function: constructor modifiers. For those of you who don't know, NatSpec is basically just comments for your code to help explain what this function, or whatever this function is about to be doing or wants to do. So I guess this would be like NatSpec right here. And so basically this finding is saying, hey, the NatSpec is missing. You should probably have that there. Again, it's not one of those things that is a vulnerability, but if you don't have, clarity around your code, future developers may have an issue whenever integrating with the team and trying to maybe add on to this function. So not necessarily something that's exploitable per se, but it could lead to some issues in the future. So that's an example of like a non-critical. It's still important to share, but it may not lead to something, big at the moment. Let's take a look at a low, for example. So let's look at this one. Owner can renounce ownership. So low severity vulnerability. So they're saying typically the contract's owner is the account that deploys the contract. As a result, the owner is able to perform certain privileged activities. The Open Zeppelin's ownable used in this project contract implements renounce ownership. This can represent a certain risk if the ownership is renounced for any other reason than by design. Renouncing ownership will leave the contract without an owner, thereby removing any functionality that is only available to the owner. So essentially, and this is actually a good one, because I know everyone just completed the fallback challenge in our activity. So the owner can only do certain things in this contract, right? So if the owner can denounce or renounce their own ownership, or let's say the owner can remove their own ownership, that can be an issue, right? Because now the contract is left without an owner, and those functions would essentially be locked down because the owner is gone. And I'm assuming that in order to add a new owner, you need those owner privileges. So this is an interesting finding, and it's one that has been marked as a low because it's not necessarily exploitable by an external user or hacker, but it's just one of those things that could potentially lead to a vulnerability in the future if they allow the owner to renounce their ownership. So that's an example of just how you read audit reports. I would expect that after this session, you guys go back and just read through these. Take a look at some of these highs. Read through the description and the recommendation. Read through some of the code and see if you can just reason about what's happening. I'm going to be honest that there are sometimes I will read an audit report and I still won't understand the high severity vulnerabilities. I'll understand a few of them, but some of them are still a struggle for me. So just wanted to share that because a lot of you may read a medium, or a lot of you may read a low and think I have no idea what that is. My suggestion, and I'm sure Robert will have something to share, is that you have to just keep trying, keep focusing in, learn a little bit every single day. And maybe after 1 week, you take a look at this report, you don't understand it. Well, go back, learn a little bit more Solidity, go look at other audit reports, go look at a few other YouTube breakdowns of things, and then come back about a week later and see if you can understand that finding. Okay, so let's jump back into the slides. And what I'm going to do, I think I am about halfway through. So what I want to do is give I'm going to ask that as students are watching this, come off mute and ask Robert a few questions. This will be a break, essentially. What you all can do is really just pause the video. I don't want to let this keep running for 5 minutes. I think at this point in time, just say, hey, Robert, we have a few questions on some of the things that Miles covered in the first half of the session. So that way you can go from there and see what kind of things that you didn't really understand in that first section. And if you're watching this later and this is on YouTube, always feel free to reach out to myself or Robert if you have any questions. If you're able to, please join the Discord and just drop your questions in there. Okay. So we're at attack vectors. So in this example here, all right, so for attack vectors are essentially different attack threads. You may hear them as attack types. You may hear them as attacks. These are just ways to break a contract. It could also be what we talked about here, a finding. EVM hooks ignore some import errors. That's an attack vector, right? So findings, attack vectors, attack threads, whatever you want to call it, that is what we're going to talk a little bit about next and how you find those things. So I wanted to share this it's a best practice blog post from Consensus, which is a reputable audit firm in the space. So they talk about the top attacks like reentrancies, Oracle manipulation, front running, and all this may sound taboo to all of you. Do not worry. This is for you all to take back, read this, and try to understand what each vulnerability is talking about. Essentially, though, these are the main attack vectors that are what causes a lot of projects to have hacks. You will see these over and over and over again, and it's very important that as a entry-level auditor, you understand all of these attack vectors. In this slide deck will be shared, so you'll have all the links, you'll have all the reports, all the blog posts that we mentioned. Next is reread these as you progress through your journey. So what we're talking about here is when we pass on these blogs, we pass on these articles that talk about common attack vectors, we talk about CTF challenges. We want you guys to make sure you're rereading and revisiting these resources throughout your audit journey, because a lot of these things it's easy to forget, and it's just really great to make sure you're building your muscle by constantly revisiting the things you have learned in the past. Next is these issues are still found in audits today, right? These common attack vectors, they're the common attack vectors for a reason. You may be able to look at a live code base and find one of these issues today. And now that would be great because this is essentially a bounty. You may be able to report this and earn some sweet funds. But these attack vectors are still commonly found. And even if developers start creating patterns to essentially prevent these, I guarantee you'll be able to find a pathway to a new attack by knowing these attack vectors. So these are just the things that you should learn as an entry-level auditor. Make sure you go and really take a look at this. We can talk more about it in our next study hall session, but we wanted to introduce these common attack vectors. We're not going to go over them per se. Robert may be able to, but the idea is you kind of start referencing this throughout your audit journey. So some of the attack vectors that we can talk about is a few of them. We have access control, we have input validation, math, and accounting errors. Talking about access control is basically understanding who has the ability to call a specific function, right? In our CTF challenges, we learned a bit about external functions, internal functions. We learned about these things, and we realized that there are some functions that you can call and some functions that you can't. So this is also a topic or a concept called being permission or permissionless. If a function call is permissioned, that means only a specific set of users or maybe a specific contract can call this function. If a function is permissionless, that is typically open to the public. Anybody can call that function. Now, if we have a DeFi protocol, or let's say we have a banking dApp, if everybody can call the withdraw function and withdraw from other users' accounts, that is an access control issue. You do not typically want to have other users having the ability to modify other people's accounts. That is a permissionless thing, and it should be permission. So this is an example of access control. So if we go through some of the access modifiers in Solidity, we have private, which is used to grant access only within the contract. We have internal, which is used to grant access within the contract and all the contracts that inherit it. We also have external, which can be called from only outside the contract. And then we have public, which can be called from inside the contract as well as outside the contract. Next, we have the attack vectors for input validation. So let's see, do I have an example? I may need to just show you all. Let's just look at, for instance, let's look at one of these code snippets, right? This may look weird. So let's look at this register function. Input validation is taking this input and making sure it is the value that you expect it to be, right? You want to make sure that if we have, and this is just an example, right? This is not specifically for this function, but if there's a function and it takes in some type of input, whatever it takes in, you want to make sure that that input is what it's supposed to be before it gets processed through this transaction. So for instance, if we're registering something and someone passes in an address, do we only allow it to be the address of specific users? Um, can it be, is it a address that has been, blocked? Should it be allowed? So these are the kinds of things you think about in terms of um, input validation. Another thing you can talk, we're going to just touch on is what happens if I pass a value of 0. If it's a DeFi application and it takes some input, if I pass in 0, does that do anything crazy? If it takes an address, do I prevent it from being the 0x address? Or can I maybe create duplicated state by putting in the same value in that function? What happens, right? And a big part of input validation is making sure you use, or the developers use, required checks. These check for conditions if they're true or false, and if they're true, the code will continue running and changing state or doing the operation it's supposed to be doing. And if it's false, it will revert and that transaction will not occur. So next we have math and accounting errors. Because we are working with DeFi protocols, we're working with applications that, deal with a lot of complex math, there could be issues with these calculations, and these issues can significantly impact not only the user, but also the protocol itself. So sometimes there are things like integer overflows, which we won't really dive too deep into today, but essentially this is what happens when the byte space of a number is overflowed, and it may loop around, and I actually don't want to go too deep into an integer overflow because I know we're dealing with people who are kind of newer to this concept. But essentially, when you have an integer overflow, it's when the byte space exceeds how the storage of what you've intended, and that can cause some issues with calculations. Next, you have division by 0. So if you divide something by 0, you're going to get an error. You're going to get a revert. So if a protocol accidentally divides by 0, that could potentially block a specific function from occurring because it always reverts. That can end up maybe causing just an unexpected action to happen. Next is the difference between less than and less than and equal to. 2 is less than 2 is different from 2 is less than or equal to 2, right? One is going to return a true, one is going to return a false. So this is something that you have to think about as an attacker when evaluating, mathematical functions. All right, so that concludes the recorded portion of this session. I'm going to pass it off to Robert, who's going to do the student CTF spotlight. So Robert, I'll go ahead and let you take the wheels. And for the students, feel free to ask Robert any questions that you have for what I just covered. Thanks, everybody, and have a good one.